Yeah, you must be, Geert, you must be overloaded with a lot of people trying to chat to you, hey?
Yeah, well, I can no longer respond to that. It's impossible. The only thing we're doing right now is we are just in the process of setting up a website where all the scientific information will be loaded. And basically we are gonna give interviews on serious platforms, not anti-vax platforms, as much as we can to get the message through, and hopefully I will not be blocked on Twitter accounts or on LinkedIn, because the pressure from the authorities and the officials and industry is of course huge to get these shots into people, and it's just basically a catastrophe.
Yes, and they can construe this as being anti-vax, but we're just pro-safety, right?
Well, they cannot. In fact, they know that I'm a seasoned vaccine guy. That's what I have been doing for the last 30 years of my career, and I keep saying that the only way to solve this crisis will be a vaccine, but a vaccine that not only protects against disease, but that also prevents infection. So that provides, in fact, sterilizing immunity, and that can eradicate these highly infectious variants that we are now struggling with.
Yeah. Anyhow, just wondering, it's 37 now. I think we're going to put up the recording. Should we start now, I think, hey?
Well, I'm fine to start now. I mean, if people want to join later on, I don't know whether you can do this while I'm speaking or while you're asking me questions. It doesn't bother me. Don't worry about formalities. I mean, there is no time for formalities anymore. So we'll come straight to the point.
Okay, because we are live on Facebook as well, so there are other people joining in by there. So, we can, yeah, there's somebody saying thank you for recording. So we will post it up on Facebook and YouTube after this as well. Okay, that's 30, 38, 39. Okay, I think your time is quite precious as well. So shall we start? Eh? Well, are you going to share your screen? Let me just share mine quickly, and then I'll lead you on here. So I think let's start now. First off, well, thank you very much, everybody, for registering and for joining us tonight. We will be recording this and putting this on YouTube, as we said, and Facebook as well after the meeting, and then we can send the links to those who couldn't attend, and anyone that are joining in now, they can just carry on listening to what Dr. Geert Vanden Bossche got to say. First of all, we just want to introduce Dr. Vanden Bossche. He received his doctorate for veterinary medicine from the University of Ghent, Belgium, and his PhD degree in virology from the University of Hohenheim, Germany. He held an adjunct faculty appointments at universities in Belgium and Germany as well. After his career in academia, Geert joined several vaccine companies such as GSK Biologicals, Novartis Vaccines, and Solvay Biologicals to serve various roles in vaccine R&D as well as in late vaccine development. Geert then moved on to join the Bill and Melinda Gates Foundation's Global Health Discovery Team in Seattle, USA, as a senior program officer. He then worked with the Global Alliance for Vaccines and Immunization, Gavi, in Geneva as Senior Ebola Program Manager, and subsequently joined the German Center for Infection Research in Cologne as Head of Vaccine Development Office. He now primarily serves as a biotech and vaccine consultant, while also conducting his own research on natural killer cell-based vaccines, which you may have to speak about a bit later, Geert. As a creative thinker, innovator, and entrepreneur and visionary, Geert has been invited to speak at multiple international congresses. And I saw that you presented in 2015 whether we should go back to the drawing board at the vaccine conference that you presented at. And then they already spoke about the immune escape, which I'm sure you're going to speak on quite extensively here. His work and supportive advice are driven by a relentless passion to translate scientific breakthrough findings into competitive solutions to emerging challenges in public and global health. So I'd like to say, everybody, just welcome a very, very experienced, highly experienced vaccinologist, if I may call you that. And thank you for sharing your precious time with us tonight. And I hope I'm pronouncing this correctly. Goedenavond, bedankt voor het lang uw expertise met ons. Hartelijk bedankt.
Perfect.
Hope that's
Thank
okay.
Yeah.
Thank you. So if you're going to share your screen, I'll, you can carry on. The floor is yours. And yeah, I think I had something to say, but I think now time's running on. So we'll say that at the end.
Yeah, but please, I mean, this should not be a monologue, so interrupt me.
Sure.
I'll just go over the slides that I presented at the Vaccine Summit in Ohio. But there will of course be tons of questions. So, but at some point we need to start with something. So yes. I think the slides may be a good way to kick off this meeting. I can already see some, chat messages from people saying, do not make it too complicated. We are not medical doctors, etc. So I don't know exactly at what level we should bring this, but let's see, and interrupt me anytime. As I was saying, there are no formalities. I have nothing to hide. You can ask me every single question, no problem. Okay, I'll try to share my screen.
Yeah, all the attendees can see and hear. Thank you very much.
Oh, okay. Good. So then I'll get started. So as I was saying, this is the presentation that I held, almost, I think, 2 weeks ago or something at the Congress in Ohio. And I changed my presentation because the situation already right then was pretty alarming. So the title of my presentation is, as you can see, why should the current COVID-19 vaccines not be used for mass vaccination during a pandemic? And literally every single word of the title is important. So first of all, we are not just talking about COVID-19 vaccines, we are talking about the current vaccines that are right now being distributed and that are being injected into people. And then what is also important is mass vaccination. So we are not talking here about injecting individuals. We're talking about really large vaccination campaigns where we are immunizing thousands and thousands of people at the same time. And the third word is also important. We do this during a pandemic. So to say, if you want to compare this with a war, a viral war, we are doing this in the midst of a war. Okay, so the vaccines that we are currently using are what we call prophylactic vaccines. So what is a prophylactic vaccine? A prophylactic vaccine is typically a vaccine that you administer to people before they get exposed to a high infectious pressure. So normally these vaccines prevent the disease or the infection. So you have to administer them before, of course, you get exposed, because otherwise they are not going to be fully effective if during the course of the vaccination, which is very often 2 injections, you get exposed to the disease and you have not a full-fledged immune response, you may catch the disease nevertheless. The second reason is that if you do your immunization, whilst you are exposed, you are at risk of immunizing somebody whilst he's already or she's already incubating the disease. And that can even lead to exacerbation of the disease. But the third reason is, of course, that if you are mounting antibodies So you get your first shot, for example, you're mounting antibodies, and whilst you're mounting your antibodies, you are already fully under attack because you are exposed to the virus. Then, in fact, the virus gets confronted with a suboptimal immune response. The immune response is not fully established. And then, of course, there is a risk, the immune response not being optimal, that the virus can escape to that immune response. So what does that mean, escape? Well, it simply means that viruses, and especially this virus, they are mutating all the time. They have a number of mutations, mostly at random, and they're not important because most of the times they do not really change the characteristics of the virus in terms of infectiousness or virulence. But if you now put the virus under pressure, under immune pressure, then of course the virus starts having a difficult time to infect people and to replicate. So in that case, the virus will start to select particular mutations that will enable to counter this immune pressure. So then the mutations that become relevant are no longer, mutations that were simply happening at random, but they are now on purpose selected to counter the immune pressure that is exerted as a result of the vaccination. And so that is, of course, very tricky, because if the virus escapes to the immune response, well, then this literally means that the virus is capable, maybe not of causing disease, because the immune response is maybe still sufficient to prevent the disease, but the virus will now be able to replicate. It will not make the patient ill, but it can still replicate and transmit. And by doing that, it enhances, of course, the propagation of immune escape variants. So what raised my attention during this pandemic, after a while, I would say it started like end of last year, that is, all of a sudden, we had several cases of severe disease that occurred in younger people. Highly infectious variants all of a sudden were popping up. And we also had, once we started vaccinating people, it just took a few weeks before we got these first reports in the literature that were documenting that people, despite the fact that they had gotten a full vaccination course, they were shedding these highly infectious variants. And this, for me, was already clearly indicating that, in fact, the virus was at least to some extent capable of escaping the host immunity, so the vaccine-induced immunity, the vaccinal antibodies. Because otherwise, you cannot really explain that people who got the full course of vaccines, that they would nevertheless transmit and shed the virus in amounts and concentrations that were clearly detectable and could be measured. So then my question was, well, aren't these cases compelling enough to demonstrate how easily COVID-19 viruses can escape host immunity? And there, I didn't need to do so, but I would have thought that some people would have gotten back to the virology or vaccinology textbooks, where it is very well known as a general rule that if you allow the virus to replicate on a background of suboptimal immune responses, that this is asking, in fact, for immune escape, especially when you're dealing with viruses that can easily insert mutations. So you can have, or you may have a problem when we talk about suboptimal immunity. It's not just that antibodies are too low. It can also be that their affinity for the virus is too low. And that is typically something that happens if you have now all of a sudden these emerging highly infectious strains that, I try to make it simple, the S protein, the spike protein of which, starts to be pretty different from the spike protein that is comprised in the vaccine. So the antibodies that are raised after injection of the vaccine will recognize the spike protein of the vaccine. And the spike protein of the vaccine is exactly the spike protein that originated from the virus or from the strain that was originally, when the pandemic started, circulating. In the meantime, other variants are circulating, and those antibodies are no longer a perfect match with the virus that is right now, or the viruses that are right now circulating. So, as I was saying, not just a matter of concentration of the antibodies, but also how well do they match with the strains that are currently circulating, and that is what we call affinity. So, because they cannot control replication completely, as I was saying, they can prevent disease, but they can no longer fully prevent replication, and hence they will drive immune escape. So does that mean that those vaccines are not safe, or are they safe? So, well, if you look at those vaccines at an individual level, they are safe. Well, I mean, they have been tested according to the prescribed and regular safety studies that are assessed, evaluated, and approved by the regulatory authorities. So, and according to these criteria, these vaccines were found to be safe. But that is at an individual level, and that is also at a short-term level. As you know, I mean, even if you do safety studies over like 1 year, in this case, safety studies were not, were conducted over a few months, maybe 3 months, 4 months, 5 months, I don't know exactly. But this is different from looking at safety, for example, at a population level. And I will explain this in my next slides, of course, that at the population level, and when administered in the heat of a pandemic, you can no longer consider these vaccines being safe. And the same applies for the efficacy. Are these vaccines efficacious? Has efficacy been proven in terms of the endpoints of the clinical studies being protection against severe disease? Well, yes, and we have heard about these percentages, which were pretty impressive. We heard about 80%, we heard about 85%, even 90%, etc. So yes, again, at an individual level, these vaccines work and protect. Again, at the population level, we are dealing with a pandemic. We are not dealing with 1 or 2 or 100 of 1,000 or 10,000 individuals being exposed to the disease. We are dealing with a pandemic, with a global infection. And there we will see that if you administer the vaccine against in the heat of a pandemic, with, of course, the purpose of generating herd immunity, that is not what we achieve. And even worse, the mass vaccination campaigns with these type of vaccines will have detrimental consequences. And I'll explain this in a minute. So it's important to distinguish between 2 different parts of the population, or 2 segments of the population. There is, first of all, folks who have a good innate immunity. These are typically kids, but also healthy people, who are in excellent or condition, good health, and they have a very strong innate immune response, which primarily exists of, for example, what we call natural antibodies. These antibodies are innate. They have a very broad spectrum, but they have low affinity, in fact, for the virus. And then we have the other population. So the NACs are the natural asymptomatic carriers. These are typically the people who will get infected, but will not develop symptoms because of their very strong innate immunity. And then you have all the other people, which I simply call non-NACs. These are people who are vulnerable. We know them very well. These are elderly people, not all of them, but in general, the vast majority maybe of elderly people, or certainly a certain or a substantial part, I should say, of the elderly people. And also, of course, people who have underlying diseases or are otherwise immune suppressed. So these people will contract the disease because of weak innate immunity, but then those who survive will develop antigen-specific antibodies, and those have the capacity to neutralize the virus, so that these people are now, when they survive the disease, they are protected through their antibodies, through antigen-specific antibodies, antibodies that are specific for the spike protein. However, when these antibody titers wane after a while, they will again become susceptible to the disease. And very often, and I was part of this club, we had a pretty naive idea or interpretation of an epidemic. So that you can see on the right-hand side, we were thinking, well, a new virus is getting into a population. It's new to the population. The population has, of course, no specific immunity. Nobody has antibodies. So those who will be protected are those who have some kind of innate immunity. Those who have weak innate immunity will be the first that fall victim to the virus. And those guys, as I just explained, they can get severe disease. But if they survive, they will automatically develop adaptive immunity, so antigen-specific antibodies. And when their titers wane, they will again be susceptible, and that is what more or less explains an epidemic where we have a wave of disease, and then after a while there is herd immunity because people get antibodies. And then when you get some depression of that immunity because antibodies wane, and well, then there can be a new surge of the virus, of the disease, and you get intermittent, for example, outbreaks. Okay, but that is not how an epidemic really works. And there is a number of things that that at least I didn't understand. And I think if you want to intervene into a pandemic, and for that matter, I would say, if you want to intervene in any complex problem, the first requirement to be able to do this, or even to have authorization to do this, is that you first of all understand the problem. So I was not understanding why a typical pandemic had, for example, 3 waves. The typical pandemic, I will show this later on, was the flu pandemic of 1918 during World War I, where there was, of course, no human intervention. It was war. I mean, there was no, people were, on the battlefield, not wearing masks, not, respecting, of course, social distancing, not continuously disinfecting hands, and so on. So there was no vaccine. So there was no human intervention. So not only are there typically 3 waves, but also typically the second wave was hitting younger people. So why did that come? And then the question is also, why was the majority of the people protected nevertheless against severe disease? We got millions of people who died, but nevertheless, the majority of people, despite contact with the virus, were protected against severe disease. And yes, I see on my screen there is still another question, but I'll primarily focus on the questions that are imprinted in FAT, because those are really very relevant. As I was saying, the infection starts with people who have a weak immunity, and I was just saying, to those who have a strong immunity, in general, younger people, are protected. So why all of a sudden then would they get the disease during the second wave? The second wave primarily affects younger people. And I think it's always very risky if there is a phenomenon that you don't really understand, that you cannot explain, and that nevertheless, without understanding, you intervene. So I'm saying here, how does that work? Why are all of a sudden people that during the first wave were naturally protected, did not develop symptoms, were asymptomatic people, they were asymptomatically infected, became susceptible? Okay, well, let me explain a little bit how the current understanding, or at least my current understanding of what is happening when you get the infection, while the virus is infecting you. And of course, if it gets into the cell, I'm not going to dwell too long on the molecular mechanisms, but it finds the receptor, of course. This is an epithelial cell at the level of the upper respiratory tract. It gets into that cell thanks to, contact or interaction with the receptor of that susceptible cell. And the virus will start to replicate. And then basically when the cycle is completed, 10 hours, it will be released from the infected cell. But there is another mechanism. There is another mechanism that takes care of the virus, in a sense that it is capable of binding to the virus, and these are the natural antibodies, immune globulin M, natural antibodies that, as I was saying, young people have a lot of them, and the concentration of those antibodies, or the stimulation of the cells that produce those antibodies, is clearly important to make sure that these antibodies maintain a certain level at the level of our upper respiratory tract. So these antibodies that are pretty different from normal antibodies, you can already see that they are, we call this multimeric. There is several of them that build a complex. This is typically the IgM. They can indeed build a complex with the, well, not only with COVID, with all kinds of coronaviruses, because remember what I was saying is that they are not specific. They can bind to several different patterns that are presented by viruses. So whether this is a coronavirus of the common cold, whether this is COVID, whether this is a variant of COVID, it doesn't matter, because the binding is not specific. And by binding to the virus, these complexes can now be internalized in what we call antigen-presenting cells. Some people may think this is complicated, but it's not complicated, because any foreign body that gets into your body will be, at some point, will be internalized into an antigen-presenting cell. So an antigen-presenting cell is basically a cell that makes the antigen, the virus, the pathogen, available for being recognized by the immune system. So it's not that these folks get in, puff, they get immediately recognized by the immune system. Yes, antibodies can do so, but antibodies are not sufficient. They need support from T cells. And in order to get this support, the antigen needs to be digested. We call this processed, digested by an antigen-presenting cell. When it gets digested into peptides, these peptides are then presented, you can see this here, on the membrane of these antigen-presenting cells. And in this way, they can be recognized by immune cells. So I'm not going to dwell too long on this, because I acknowledge that some people have more in-depth knowledge of immunology than others. But in case of COVID, this leads to stimulation, most likely of NK cells, natural killer cells. Why I'm saying most likely? Because we find out, well, that's not we, that's simply researchers who have published this, that people who recover from, not recovering, sorry, that do not develop symptoms, that are infected but without developing symptoms, they have strong proliferation of natural killer cells. And that is not typically seen in people who do develop severe disease. On the contrary, there the natural killer cells get rather depleted. So, but why am I telling this whole story? Because it's so important. This means that if you have good natural antibodies, the antibodies will enable the virus to get internalized into dendritic cells And those dendritic cells will present to natural killer cells. And now these natural killer cells, they will now be able to kill cells that have a similar pattern on their surface. And which are the cells that have a similar pattern? These are, of course, the cells that have been infected by the virus. So asymptomatically infected people, they activate NK cells, natural killer cells, are part of the innate immune system. And by activation of those cells, these people are capable of eliminating virus-infected cells at a very early stage of infection, because they recognize viral patterns that are similar to the patterns that are presented on the antigen-presenting cells that have internalized the virus by means or by virtue of the natural antibodies. So in other terms, this means that if you are asymptomatically infected, it simply means that you get almost immediate activation of NK cells, that those NK cells take care of the virus-infected cells, and hence nothing happens because the infection cannot go on. The infection gets abrogated at this stage. And so these folks will maybe shed virus for a few days, low concentrations, and that's it. Whereas other people who have no natural, well, everybody has natural antibodies, but as you can imagine, it's a matter of concentration. If levels are too low, this internalization mechanism and hence the activation of NK cells will not take place, and these people will go on, the infection will go on, and more cells will get infected, and at the end the infection in the upper respiratory tract will go down to the lower respiratory tract, and then you have the whole symptomatology with the inflammatory cytokines, etc. And these are the patients who, of course, get severely ill. So is there any question at this point? Clarification? No? Then I'll just continue.
So I think as an ENT, I might speak about some ENT stuff later, but carry on. I think just keep going. Thank you.
Yeah. So what is the single most important thing to understand in the whole, we call this with a complicated word, pathogenesis of the disease of COVID? The single most important thing to understand is, don't look at the slide, listen to what I'm telling, and then we'll go to the slide. The most important and very strange observation is that people who get asymptomatically infected, all of a sudden, they develop antibodies. But they do develop these antibodies, in fact, after the virus got already almost eliminated by the NK cells, as I just showed. So they shed virus, they eliminate it, and you see afterwards they start developing antibodies. But these antibodies are short-lived. They last for maybe 6 weeks, or in some people maybe less. Anyway, in all people, these antibodies are no longer detectable after 8 weeks. So I was asking myself, what is the purpose of these antibodies? The purpose is certainly not to eliminate the virus or to neutralize the virus, because that has already taken place by the NK cells. I mean, if that would be the purpose of the antibodies would come before the elimination of the virus, right? Because they would be needed to eliminate the virus. It's exactly the other way around. So now it's very important, and still don't look at the slide, listen to what I'm telling, because this is critical. These antibodies, this short-lived surge of antibodies after somebody gets asymptomatically infected, are of course antigen-specific antibodies. These are exactly the same type of antibodies that you get when you get a disease. But first of all, they are short-lived. They are probably not fully mature because there is, it's only short-lived and there is no boost effect. They are not, these titers are not very high. And so they can still bind, in fact, to the virus. So, but they don't bind strong enough to prevent the infection. And that's also not needed because the infection is already taken care of by the NK cells. So what is the purpose of these antibodies? Well, you have to imagine when during the first wave, I explained to you, vulnerable people get the infection. So what happens is that the virus will spread because more people get infected. And at some point, the virus will be widely distributed in the population so that now people who got during the first wave got asymptomatically infected get, for example, reinfected with the virus, right? So when they get reinfected with the virus, at the very moment where they have still this short-lived surge in antibodies, they become very vulnerable. Why is this? And this is important to understand because remember, we started the discussion with saying, or with the question, why on earth all of a sudden does the wave of disease and death shift from the elderly to the younger population? So, and now I allow you, so to say, to look at the slide. These are the antigen-specific antibodies that I am talking about, that, the short-lived surge of antibodies. And these are the antibodies that I just showed you, which are the natural antibodies. So the antigen-specific antibodies can, of course, there is nothing new, don't worry, can bind to the virus, whether it is, this is, for example, an infectious variant, can bind to the virus. Of course, they will bind, these are, the antibodies will bind very strong to, or stronger to the original virus. If in the meantime the virus changes, well, the same antibodies will have less affinity, of course, for the variant. But what is important to understand is that these antigen-specific antibodies are able to outcompete the natural antibodies. Remember, the natural antibodies are not antigen-specific. They are, we call this multi-antigen specific. So that means they can recognize a multitude of conserved patterns that you find, for example, on viruses, but that you can also find on cells, etc. And they have low affinity for the virus. Their advantage is they don't care whether they're dealing with, the original virus, whether they're dealing with a variant. They don't care because they can recognize all these folks. They can recognize any coronavirus, right? So that is fantastic. But the disadvantage is that they have low specificity, especially for the spike protein. So in terms of binding to the S protein, they are always outcompeted by the antigen-specific antibodies. So as soon as you have antigen-specific antibodies, like for example in asymptomatically infected people, even though these antibodies will have no role to play in protection, and that's not necessary because the NK cells are taking care of this, they will always be able to outcompete the natural antibodies for binding to the spike protein. And why is this important? This is important because it is the very spike protein that is responsible for infecting the susceptible cells through the receptor. This binding, this is through the spike protein. So in other words, the folks that have had during the first wave asymptomatic infection, they have the short-lived antibodies. And you could say, well, why? What is the purpose of this? Well, these antibodies allow to outcompete the natural antibodies. By doing that, by outcompeting the natural antibodies, the subject becomes, of course, more susceptible because it's like, you don't have the natural antibodies anymore. They're outcompeted. And the specific antibodies, I was just saying, they will still bind to the spike protein, but their concentration does no longer suffice to prevent the virus from recognizing and docking on this receptor on the susceptible cell. Do you get it? Because this is critical. So now what I'm saying is that remember, you have the first wave, more and more people get infected, and all of a sudden, I say this very slowly so that you can catch it very well. All of a sudden, the likelihood that somebody, an asymptomatically infected carrier who has short-lived antibodies, will get reinfected by this virus becomes higher. So I'm repeating, as the virus spread during the first wave and more people get infected and the infectious pressure is mounting, the likelihood that somebody who has a short-lived surge in antibodies will get reinfected becomes higher and higher. So that means the likelihood that somebody gets momentarily a suppression of the innate immune system gets higher and higher. And that is how the virus will now be able to make younger people ill, because they will have a momentary suppression of their innate immunity because they got hit by the virus at the very moment where they had these short-lived antibodies. Do people understand this? I mean, I do my very best to make this simple, but because the consequences of this are just huge.
Thanks, Geert. Yeah, we noticed here in South Africa, the second wave seemed to have a more devastating effect on the young people.
Yeah, well, it's everywhere.
Younger people as well. Yes.
Yeah, everybody's talking about, you know, like in Europe, third wave, and no. I mean, we have been intervening in this pandemic with very stringent infection prevention measures, have given the virus a very tough time. The virus has reacted to this by becoming more infectious. That is where the highly infectious variants come from. And now what we are seeing is that the first wave got abrogated when during summer, at least here in our countries, during summer, the prevention measures were relaxed. Then the wave came back and people were saying this is a second wave. No, no, no. This was, in fact, the remnant of the first wave. And now we are shifting to the second wave and seeing more and more youngsters infected. And this is because their innate immunity gets suppressed because the infection has now spread so broadly that youngsters who were asymptomatically infected during the first wave are now increasingly likely of re-encountering the virus while they are having still antibodies, although these antibodies don't last very long. And so now the virus is able, you know, to in fact make young children even or younger people ill. And that is what we are seeing right now. So what I'm saying here is that short-lived antigen-specific antibodies suppress binding of coronaviruses in general by natural antibodies and dampen innate immunity. So asymptomatic infection momentarily weakens the innate immunity without facilitating viral clearance. So because the antibodies that they have, they are not responsible for viral clearance. But by dampening the innate immunity, they become more susceptible, of course, to the disease. And as I was saying, that's what we are seeing right now. So you have to imagine, so how does it work? I mean, I in fact explained it already. This increasing COVID or coronavirus, I mean, it's infection rates promote enhancement of innate immune suppression in people that during the first wave were asymptomatically infected. So it's like you have these people, the vulnerable people, the first wave, they get infected, and you can see more and more people get the disease. But not all of the, for example, elderly people are going to get the disease. No, only those who have a weakened innate immune system. So the capacity for the virus to make people ill is limited. And that is a problem for the virus, because the virus is not interested in you know, making people or just infecting people without people having symptoms. Why? Because if you have no symptoms, you're barely shedding virus. You're shedding virus maybe for a few days at low concentration. But if you get a disease, then you will shed virus at higher concentration and over a prolonged period of time. So you can see this reservoir is limited. But there is no problem, because as this diminishes, the infectious pressures is increasing, and the people who got asymptomatically infected during the first wave now become susceptible, because the likelihood that they encounter the virus during the short time increase of their antibodies increases. So their immune system, their innate immune system gets suppressed, they become susceptible to the disease. And so the virus is jumping from one population to another, and this is important, without any need to increase its infectiousness. Because what is happening after this, again, the capacity or the reservoir of the young people that are prone to disease is limited. It's not because the virus will suppress your innate immunity that every youngster or every subject that got asymptomatically infected during the first wave is going to get ill. Certainly not, because it depends on what level of innate immunity you still have. So what I'm saying is that the number of people that can get a disease, even amongst youngsters, is limited. So the virus starts to have a problem because it can no longer make people ill in this group. Well, no worries. Why? Because in the meantime, those folks start losing their antibodies. Their antibodies titers start to wane. So they become again susceptible. And hence, in the third wave, the virus is jumping back to this population, again, without any need for the virus to become more infectious. So if you like, the strain that comes in at the beginning of the pandemic and then leaves, so to say, the pandemic is the same. Why I'm saying leave the pandemic? Well, what happens? When these folks get reinfected again, they immediately mount an immune response. Why? Because they have been infected, they have seen the virus, they have what we call an immunologic memory, an immunological memory. So they can mount antibodies very, very rapidly. So the virus has barely any chance really to spread broadly. And you could say, well, it can go back to the youngsters again. No, same thing happened there. They have a certain portion of them have been ill and have mounted antibodies. So when they now see the virus again, they will immediately boost these antibodies. And other folks, they have still their strong innate immunity. They are not really affected because, you know, their innate immunity is strong enough. So that is how during or after the natural course, without human intervention, we get herd immunity. We get herd immunity, and the virus, you know, continues maybe to survive in the population and will take advantage of any weakness when, for example, you have this closed groups where people live in certain communities, or you have immigrants, for example, that come from another region that have not seen the virus, that have no immunological memory of coronavirus. Well, those people may be susceptible and the virus may flare up, but it can no longer spread to the part of the population that has seen the virus already. Well, it can spread, but they will immediately, due to their immunological memory, come with their antibodies, and the virus will have no chance to broadly spread. So it can be an epidemic, or it can be just a local outbreak, but that is the end basically of the pandemic, right? So, okay, so what is now, what are we currently doing, we human beings? How are we intervening? Well, we have been intervening. You don't have to look at this because that is just what I showed in the previous slide. And I also told you that, well, in fact, the virus is always leaving the door open for increasing its infectiousness. How does the virus do this? Well, you have to remember, I was saying at some point in time, the virus will reinfect people, asymptomatic carriers that have a short-lived, a surge in antibodies. And here you see already that you have a situation during the pandemic where the virus is infecting people with a suboptimal immune response. So this surge in antibodies after somebody got asymptomatically infected, as I was saying, it's short-lived. Titers are not as high as people who got symptomatically infected. So this response is suboptimal. It's suboptimal, but as long as the virus can easily jump again to elderly people, for example, who have antibody titers that are waning and become susceptible again, there is no reason for the virus to escape. But if we put it under pressure, for example, we prevent the virus from spreading, we exert a huge pressure on the virus by all these infection prevention measures, by the social, the physical distancing, by the masks, etc. At that point, the perpetuation of the virus is threatened. The virus is really struggling to survive, and it will take advantage of this suboptimal immune response to escape to that immune response and to escape to the antibodies. And what is happening then is, I will show you in the previous slide, what is happening is that even though these antibodies will not prevent the virus from binding, they will still make life more difficult for the virus because they are sitting on the spike protein. So if you now can escape this immune response, well, there is no single antibody sitting on this virus anymore, and it can much better bind to the receptor. So that is what the virus will do if you start, preventing it or hindering its spread through all these infection prevention measures. So that is where you see that already as a result of the infection prevention measures, we got all of a sudden, don't know exactly how it was in your country, but we here in Europe, all of a sudden, end November, something like that, last year, we saw all these infectious strains all of a sudden coming up. And frankly speaking, that is where I got alerted, because I just told you, during a natural pandemic, the virus has no need to do this. And when I saw this, I got immediately alerted. I thought something is completely wrong here. This is not normal. This has never, ever been described during any other pandemic, as far as pandemics have been documented. So that is one thing. So the other thing is, of course, as I was saying, from here, the virus can again normally, during a natural pandemic, spread to these folks when their antibody titers start to wane. But what if you don't give those folks, an opportunity to have their antibodies wane because you're vaccinating them? You vaccinate them, so now there is no way for the virus to shift back again to this population, because their antibodies are not waning. They're all. We do mass vaccination. We start vaccinating elderly and vulnerable people in mass. So then the virus has no other chance but to become more infectious in the younger people. Why? Because if it becomes more infectious, it can take a bigger part of the youngsters and make them ill, what will ensure its propagation. And so we see increasing infectiousness, increasingly infectious strains that now are in several of our countries making youngsters ill. We now see children, we see teenagers in our hospitals. And of course, if that continues, because the virus cannot leave this group, it needs to further select mutations to become, to bind stronger and stronger to the receptor, and that the S protein changes in a way that it can overcome this immune pressure and more strongly bind to the receptor. All of a sudden, of course, we will drive the virus to select mutations that are able to even resist, to further resist the antibodies that are induced by the vaccine. And when that happens, of course, this population, this means the people who have been vaccinated, basically, all of a sudden, are completely susceptible. Why? Because their antibodies, they are worthless, because the virus becomes resistant against these antibodies, and they have not good innate immunity. That is why during the first wave, they were the first to get a disease, right? So these people are almost left without any valuable, reliable immune response, right? So that is the short story. If you understand this, you basically understand my story, because that is what I'm saying. What if these antibodies in the elderly, so in these folks, what happens when these antibodies don't drop? Because we vaccinate them. Then, of course, there is no other way for the virus to continue elaborating and further working on this S protein to make it bind so strongly to the receptor that it binds, in fact, more strongly, the receptor binds more strongly to the virus than that it binds to the vaccinal antibodies. So the vaccinal antibodies are, so to say, outcompeted, because the virus, by means of mutations that are selected in the S protein, binds with increasing strength to the receptor. And that is what we are going to see, or that what we are already seeing, because, and I will stop there and leave it open for questions. As you know very well, the protection against, for example, South African and Brazilian strains, even against disease, is right now, down to something like maybe 30%. And protection against infection is completely absent. I mean, we turn, with these vaccines, in other words, we turn people into asymptomatic shedders, because none of these vaccines can prevent people from shedding the virus, especially not since the circulating strains right now are highly infectious and their spike protein does no longer match with the S protein, the spike protein that is in the vaccine. Okay? So please, over to you.
So when you do have antibodies, it doesn't mean that you are going to be protected when you get the second infection.
When you have antibodies that result from previous disease, people who got the disease during the first wave, they will develop very strong antibody responses, and they are, of course, protected, but they are not necessarily protected to the highly infectious strains. Because what is important to understand, we are not dealing with one pandemic. We are dealing with it since the highly infectious strains emerged. We are dealing with a new pandemic. This is a new virus. I mean, our antibodies, have not been raised against those folks. Okay, there is some cross-reactivity, but it is limited. It is certainly not sufficient to prevent people with high titers of antibodies against the original strain to not shed the virus. On the contrary, they will shed the virus. And what I was saying just a minute ago is that even now, these people are increasingly no longer protected against the disease. If you talk about, South African strain or Brazilian strain, etc.
Well, we had a million doses of AstraZeneca vaccines that were delivered, and by the time they arrived, they were found to be much lower efficacy against the strain that we have here now. So they were, I'm not sure how far, but they've had to abandon that vaccine. So now, you see, there's the mRNA vaccine and the adenovirus vector vaccine, and the other new ones coming out. Are these vaccines all stimulating the antibody side of your immune system, or do they all do that? Are they all in a similar kind of stimulation of our immune system?
Let's be very clear. Of course, these vaccines, there is difference in the type of immune response that they're stimulating. And people will say, oh yeah, but they are strongly stimulating T cells, etc. So all of these vaccines, let's be very clear, stimulate T cells, helper T cells. If you don't have helper T cells, I mean, you have no antibodies. Yeah, well, you have antibodies, but short-lived, immature, etc. In order to have a decent, full-fledged antibody response, you need to have T help. That's very clear. But then they are saying, oh, wow, there is plenty also of CD8 responses, CD8 T cells. Does that ring a bell, or is another type of T cells, of course, right? But I mean, the short answer to that question is, I mean, who cares about any type of T cell if that T cell is not capable of killing a cell that is infected with a virus, right? That is what we need. A virus gets in, either the virus is free floating and the antibodies capture it and can eliminate it. But as I was saying here, if the antibodies are no longer preventing the virus from infecting a cell, what you need is a cell that is capable of killing the cell that is infected, right? And all these talks and all these publications of CD8 T cells and blah, 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 blah. And then I'm asking, have you shown that these cells are capable of killing a virus-infected cell? Such a cell is called a CTL, cytotoxic T cell. And I'm not saying that these cells do not occur, because ultimately, when you get a disease, I mean, some people unfortunately die, but others recover. Well, most likely, these are CD8 T cells that then acquire cytotoxic activity that can ultimately eliminate the virus. But then the problem is, this does not apply to anybody, because, and now we get more to the details of immunology, whether a CD8 T cell will effectively be so strongly stimulated that that cell develops cytotoxic activity will depend on how well that peptide, that CD8 peptide, matches your HLA, antigen presenting molecule, right? If that is a good match, well, these people can be lucky and eliminate the virus. If that's not a good match, for example, you may develop plenty of CD8 T cells, but those CD8 T cells, because they have no cytolytic capacity, will not be able to kill virus-infected cells, right? This is a little bit complicated, but yeah. I mean, things are not, I'm not saying that these things are easy. That's what I'm always saying. So we are dealing here. So, and that is very simple, what I'm going to tell right now. We are dealing with the following situation. We don't even understand, or those who all of a sudden decided to implement mass vaccination do not or did not understand the natural course of a pandemic without human intervention. And that is what I just explained a few minutes ago. So first of all, if you don't understand the natural course of a pandemic, I'm always saying you have no right to speak. But it's much, much worse than that, because we don't even understand, and that you can read in every single paper on COVID, we don't really fully grasp the pathophysiology of this virus and the immune pathology and how exactly it interacts with the immune system. And then we don't really understand that, in fact, when you are exposed to a high infectious pressure in the midst of a pandemic, you cannot really use these prophylactic vaccines. So what I'm saying is that we are going to a war. We don't know our enemy because we don't understand the pathophysiology of the virus. We don't understand the strategy, how is the war structured, because we don't even understand the natural course of a pandemic. And we don't understand how to use our weapon, because we are using prophylactic vaccines in people that are heavily exposed already to the virus. So what is the likelihood that you are going to win this? Where are the publications, the scientific publications, that show that in such situation where you use prophylactic vaccines in the heat of the war, in the heat of the pandemic, and you use them massively, right? And you don't even understand what the enemy is doing, because you don't understand the natural course of the pandemic, and you don't understand the physiopathology of the virus. I mean, where is the science that allows us to say that this is going to have a happy end? And that is why I'm saying, and just based on the science, this is one big experiment. I'm not an anti-vaxxer because I've spent 30 years of my life on vaccines and all the disciplines that go with vaccinology, immunology, infectious diseases, virology, even biophysics, because if you study the binding of a virus to a receptor and the binding of antibodies to a virus and the binding of multimeric antibodies versus highly specific antibodies, the difference between affinity and avidity, etc., that goes into the domain of biophysics, right? So that is what I don't understand, that, you know, we take decisions on, it's all about, people tell me, oh, Geert, your theory, you know, you have not published this in a peer-reviewed journal. And I'm saying, first of all, I have, of course, a response to this, because first of all, I'm saying, well, I'm ringing the alarm bell. And if my house is ablaze, I'm not going to first write a report what could be the potential consequences of not extinguishing this fire, and do experts agree that my report is correct, and can they please return it to me so that I can approve this and that I can proceed with, you know, extinguishing the fire. I mean, this is ridiculous. You take whatever you can, right, to fight a fire immediately, right? That is one thing. The second thing is, if I would submit this, you know, to a peer-reviewed journal, who are my peers? These are the people that I'm now asking, begging to engage in the scientific discussion, and that who refuse this, right? These are going to be the people who review the journal. So I know there is no way that we will get through with this. And then I'm asking the question, where is your scientific evidence that you can do a thing like this? Because everybody will understand that if you do this at this large scale, at this massive scale, there is only two possibilities. Either you are going to have a tremendous success, or you are going to cause a tremendous disaster. And I'm not a drama queen, not at all. But I mean, I base myself on the science, and I put all these pieces of the puzzle together. I did my homework. I looked into the pathogenesis of the virus. I looked at the immunology. I looked at all the questions that I could not resolve, and, you know, was studying day and night to solve this, right? And it's only, all these pieces are available. I've posted on LinkedIn, and we will have our website ready to go in a few days from now. All the scientific evidence, all the pieces of the puzzle will be in there. But of course, you know, the puzzle itself, you will need the vaccinology, epidemiology. This is a complex thing. This is a pandemic, for God's sake. I mean, this is the interaction, evolutionary shaped, between a virus and the immune system. And, you know, there's several disciplines involved, immunology and virology and infectious diseases and etc. This is very, very complex. And then we intervene in this pandemic, you know, with massive infection prevention measures, with mass vaccination. I mean, this is not very easy to understand. That is not easy to unravel. You have to do your homework, right? But I did my homework, and everybody knows, everybody who knows me knows that I'm extremely serious about this, and that I challenge, you know, Anthony Fauci can, you know, I'm willing to immediately enter into the scientific debate, you know, any top scientist. But the problem is that these top scientists most likely understand very well what I'm saying, but nobody is willing to open the debate. I'm not even saying stop mass vaccination tomorrow. No, I'm telling them, I'm begging them to engage in a very serious scientific debate. Where are the people who have done the homework and, you know, the vaccinology, the immunology, infectious diseases, etc., and brought all these disciplines together in order to be able to solve a problem that could be one of the biggest problems ever, you know, in the history of mankind, primarily because of human intervention, right? If you study a pandemic seriously, the conclusion is very easy. Again, everybody can understand this. In fact, the pandemic has the three waves, then there is herd immunity, and then it calms down. Well, I can tell you, if you study this in detail, you have to conclude that, in fact, the virus is not taking any life more than strictly necessary to ensure its perpetuation, right? And also asking the people, what was the end game of the vaccination? The end game, the purpose, the end point, I should say, was, come, let's sing it all together, herd immunity. That was the thing, herd immunity. So now you explain me, if you vaccinate people, like, for example, in your country with the current vaccines, and they barely protect, and people, after being vaccinated, they shed virus like hell, where is the herd immunity? Because for those who are not familiar, I will repeat this, herd immunity is, in fact, we talk about herd immunity when you immunize a certain percentage of the population so that they can, maybe not completely, but to a large extent, prevent the virus from replicating and being shed. And so
I think the figure is about 60%, isn't it?
Yeah, I don't care about these things. 60% or 70, this is, this is for those who like, to discuss and to model. But anyway, what we are doing right now is exactly the opposite. Instead of preventing the vaccinees from shedding virus, and by doing so, protecting those who are not immunized, who are vulnerable, we turn them into asymptomatic spreaders, right? Because the highly infectious strains are circulating right now, and we are coming with vaccines that are not fully protective, certainly not against infection. So we are doing exactly the opposite from generating herd immunity. And I mean, frankly speaking, there is a consensus, a worldwide consensus right now, that we will not achieve herd immunity with these mass vaccination campaigns. So what the hell are we doing?
That's a very scary thought. Huh? So I've got a couple of questions I'd like to ask here now. So would it be ideal if 60% of the population got vaccinated all at once?
Yeah, that's a good question. Well, to be very open, I mean, there is people who are much better positioned than I am to exactly, pronounce themselves about those figures. It could be 60%, it could be 70%. But remember, if you would be able to vaccinate all these people at the same time, then you may have a very beneficial effect, because then it's almost like the same situation like you have a prophylactic vaccine. Here an individual is protected before they get exposed. Here you would have the vast majority of the population protected before they get exposed. Even during a pandemic, I mean, if all of a sudden you could mount these immune responses so high, you could have this effect. But frankly speaking, all these discussions have become completely irrelevant, because we are now dealing with highly infectious strains, several of them, and these are all different, it's all a different story. So, I mean, whether this is with the vaccine or the natural immunity against the original strain, forget about this. This is not what you're going to give herd immunity. So,
practically, it's not going to be practical. Just from a logistic point of view, it's not easy to vaccinate 60-70% of the population at once. And so because with the variants coming out there, so with the vaccines that say that you have to have one shot, will they have to have a second shot or a third shot in the future when the variants come about?
We are always running behind. Please don't forget the replication cycle of a virus. It's 10 hours, right? And we are chasing 10 hours. 10 hours is a new generation of viral particles. And if that virus needs to select mutations, it will do it. And what is happening is that if you vaccinate people, the more you vaccinate people, this virus that is trying to escape and landing in another body that is also under immune pressure because it got vaccinated. I mean, this immune escape virus variant will get more and more established, of course, right? So, and I mean, you have, because I'm only telling part of the story for the sake of time, but imagine, what do you think is happening with all those folks who got their first shot I mean, their weapon is not ready, and they are already fully under attack. We give them one shot. I mean, do we put these people in quarantine or do we isolate them? I mean, they just go and they get exposed to the virus with a suboptimal immune response, right? So what is this doing? Driving immune escape like hell. So there are several different situations in this pandemic. In the pandemic, like we artificially now manipulated it, where the virus is encountering a suboptimal immune response. And we put it under pressure. So the virus is saying, oh, come on, guys. I mean, I have plenty of choices here. There's plenty of mutations I can choose. And I will choose those that enable me to counter the pressure that you're putting on me. It's as easy as that. I mean, this is not rocket science, right? I mean, this is the laws of Darwin, basic biology, right? And it cannot be that this is ignored. I'm not a super intellectual guy. I've just done my homework, put the pieces of the puzzle together. And I mean, every biologist, every biochemist, every immunologist, every virologist, you name it. I mean, when you show them these pieces of the puzzle and they have, the kind of explanation that I'm continuously providing, they immediately know what I'm talking about, right? And I can tell you, if I would make fundamental mistakes and violate, the laws of biology, immunology, vaccinology, you name it, you can imagine how many people would heavily criticize me, publicly, etc. It's not happening. It's silence. Yeah. Of course, a number of people are reacting, and we have some discussions, etc. But from those guys, the health authorities, the national authorities, those who are responsible, I mean. There is no answer. There is. I don't even ask them, to take a decision. I'm just inviting them, for God's sake, to open the scientific debate on what is going on, because the consequences are just unbelievable.
Well, it's very scary. And I know you've written an open letter to World Health Organization as well. Have you heard anything from them?
What do you think, But the answer is?
Okay, probably silence. A third question I'd like to ask you, Geert, is so now places like I think United States, the UK, and Israel have been most vaccinated, and now everybody's talking about expecting a third wave. How's this going to affect the third wave of the virus?
Well, as I was saying, remember, we can go back to this slide, right? I mean, we had more or less the first wave, and then of course you massively vaccinate, and of course the virus will have an extremely difficult time, because all of a sudden there is now a number of people that mounts antibodies, vaccinal antibodies, and the variants are not, well, there is still some activity, of course, of the antibodies, certainly in terms of protection against disease on the variants, and certainly also to some extent on infection. So I'm not saying that if you get a vaccine and you get infected with a variant, that this will have no single impact whatsoever on the amount of virus shed. I'm certainly not saying this, but it will still allow the virus to be shed. But anyway, if you now immunize within a few weeks millions of people, of course the infectious pressure will go down. Of course, you will have less people who get the disease, etc. But the virus got a terrible blow, but it's not. It can still replicate. It can still replicate. Remember, these strains now are highly infectious. It doesn't take a lot for the virus, to infect you. 1 meter, 2 meters distance. I mean, highly infectious. That means that for the same number of particles, with the same number of viral particles, you can basically infect many more people, right? And so the virus, of course, is suffering, but you will see it cannot go anywhere. It cannot go to these people, the vulnerables who are now vaccinated, etc. So there is two things that we are going to see. It will dramatically affect this population. So the curves will go up again. How steep? I don't know, but I guess pretty steep. And it will essentially affect the youngsters, right? The young people. And that is a catastrophe. And I don't know. I'm not searching. I'm not all the time, on all kinds of broadcasting channels and so on. But what I'm hearing is that it's not going very well in Israel. What I'm hearing is that it's not going very well in Gibraltar. And since the vaccination campaigns, I also heard quite recently that there is more and more infectious, highly infectious strains popping up in the UK, for example, right? So
that is great.
Yeah.
So what do you think of this vaccine passport and the green card, that if you're vaccinated, then you're allowed to go flying and allowed to go see shows and that, and if you're not vaccinated, you're not allowed to go? What is your comment on that?
My answer to that is very simple. Very simple. I think in 1 or 2 weeks from now, no authority will still dare, to, I would say, couple any type of restrictions or any type of advantages to having a passport or not having a passport, because we will see the damage that this mass vaccination will do. Because of course, I mean, till now, of course, people, they don't believe me and they come with all kinds of different stories. And I tell them, but unfortunately, it is too late, because the pandemic is right now already out of control. But I tell them, well, look at those countries that have implemented really with a big success these mass vaccination campaigns: Gibraltar, the UK, Israel. And when you will see that after a decline that we have been seeing, of course, in the last few weeks, you will see all of a sudden that despite increasing vaccine coverage, you see these curves going up quite steeply. I mean, is there any other conclusion then than, to admit that the vaccination is not really, a very successful initiative? Not only not very successful, but that, the curves of disease and death, mortality and morbidity are again, going up. I think there is no other factor that you can make responsible, or that, that you can blame. Maybe 20% of the people will not be vaccinated. Will they say, oh, it's because of this 20%, we now need to vaccinate this 20% as well? I think, the credibility will no longer be there. So I'm not even worried about all these stupid discussions that are now going on with regard to passport or no passport, etc. Forget about it. It will become so irrelevant. You won't believe it. Yeah.
Because certainly in Israel, they're enforcing it quite strictly.
Yeah.
And so these prophylactic vaccines, if the timing was different, when would be the ideal time to give a prophylactic vaccine? Obviously not in a pandemic setting, but then if it's not going to be infectious, then there's no rush to get a vaccine. Or do you understand what I'm trying to say? When is the best timing to get a prophylactic vaccines that we're getting now?
Well, it's for all prophylactic vaccines that do not induce sterilizing immunity, so that cannot prevent the virus from replicating and spreading. It's always the same rule. You have to give it before you get exposed really to the virus, right? Because then if you have antibodies, and several people have antibodies, for example, the virus comes in, it gets immediately, knocked out. And even if still it can a little bit replicate and spread, the frequency or the likelihood that the virus will, spread in concentrations large enough to infect, other people, etc., will be so low that, the virus will have no chance. But that is very, very different from a pandemic situation, of course. So indeed, yeah, you can use this vaccine. I've never said that these vaccines are not good vaccines. I mean, these are vaccines made by brilliant people, you know, very professional companies. There's no, yeah, and some are better than the other maybe, and some have more side effects or et cetera, et cetera. But you cannot use a vaccine that only prevents the disease but not infection in the midst of a war, right? And you know, you will be continuously being loading your weapon. You get your first shot, you know, you're mounting antibodies. I told you the history of the asymptomatic infected people who are also confronted with the virus while they are not having optimal antibody titers. Remember the short-lived antibodies? So you're continuously, you know, confronting the virus with an immune system with antibodies that are not optimal. And the virus will say, well, I think this is very annoying, so I'm going to do something about this. And the virus will select mutations that will just overcome it, just to ensure its perpetuation, its replication. That's it.
So there are quite a few questions. I'd just like to ask you a couple more, please. So when you talk about sterilizing immunity, you're probably referring to the killer cell, the NK the vaccine that's being developed, or
well, not necessarily. Not necessarily. I mean, of course, we could discuss for hours on this. But remember, I mean, we got smallpox eradicated. We got almost, you know, polio eradicated. I don't know whether you remember what type of vaccines we were using. I mean, it was before my time. Well, not the polio because still not entirely eradicated, but smallpox. What type of vaccines we were using? I mean, these were not subunit vaccines. These were not inactivated vaccines. These were live vaccines.
Probably a lower dose, right?
They were live vaccines, vaccines that were able, of course, to replicate, that were inducing local immunity, at least for polio, because it was oral immunization, right? They were also certainly stimulating a lot innate immunity, right? Well, innate immunity, I mean natural antibodies. So there we were really exploiting all several different arms of the immune system. And it's the first time I'm saying this in an interview, but if things really explode, I mean, it's going to be difficult to intervene, but, and I'm not advocating to use a live attenuated coronavirus, but I would definitely say that live attenuated coronavirus, where of course you would have some casualties of people who have weak innate immunity, like with polio, 1 in, I don't know exactly, 200,000 people may still get the disease. That is severe disease, poliomyelitis. With coronavirus, somebody who would get the disease, we could probably treat it, right? But a live attenuated coronavirus vaccine would definitely have made much more sense. But people will not administer a vaccine to somebody if there is a chance that that child, that person being in perfect health, could become the disease as a consequence of the vaccine. Because even with poliovirus, I was saying 1 in 200,000, maybe it's 1 in 500,000. I'm not sure about this, but that has been sufficient to really, you know, shift from the oral live vaccine to an inactivated polio vaccine. So if you now come, you know, after with all our modern technologies and all our sophistication, you would go back, you know, to the ancient time of vaccinology, where you say, guys, I mean, probably a better way to do business here would be to use a live attenuated coronavirus. And people would say, well, wait a minute. I mean, some people are going to start coughing, others maybe get, you know, pneumonia, maybe, etc. We cannot do this. And so then we have the modern technologies. It's all very, you inject this, okay. Vast majority of people, you know, have not a lot of problems. I know there are some side effects reported, but it
Mm.
was considered, at least it was considered that these vaccines, that the reactogenicity and side effects would be very, very minimal. Very modern vaccines, only subunit. When you administer this as a protein or an mRNA, I mean, it's in fact the same story, because the mRNA will synthesize the protein in vivo and etc. So these are very clean, highly, pure vaccines, very well characterized, etc., etc. So this is modern style, right? But of course, as we see, and I'm repeating myself, not adequate for the kind of war we are facing, or we are engaged in.
Why I'm bringing that up is that a fellow South African who immigrated to the States is coming back to South Africa, and he's also working on a killer T-cell vaccine as well that you can take orally. So that might be something interesting for the two to get together,
Well, there is, with regard to the NK killer cells, all I'm going to say is that I try to explain you in the slide, and everything is public. All I'm saying, all the things that I put together based on science and sources from the literature, you will see it on our website, you will see it on LinkedIn or whatever. But what I will say is that, as I showed you, you still see this slide here, where in fact the virus itself is showing us how we can eliminate it, in a way that it can no longer replicate, really abrogate the infection. That is what the NK cells are doing with asymptomatically infected people. Asymptomatically infected people, abrogate the infection, not due to antibodies, but due to killer cells, right? And shouldn't that be a hint? Shouldn't that inform us or show us an interesting path as to how we could possibly intervene in a way that we really get rid of the virus? Because frankly speaking, nobody knows. Nobody is telling me. I don't know how otherwise we could ever get rid of these highly infectious strains. How are we, going to get rid of those? Nobody tells us. Nobody tells us. I mean, they are going to be around forever. We cannot live with these highly infectious strains. It's impossible. So we need to do something about this. So these guys here and the natural antibodies, they're saying, Geert, Ivan, don't care about variants, because we can take care of all these beasts, because this is non-specific immunity, right? It recognizes pathogen-associated patterns on cells, etc. So whether this is coronavirus, even other viruses, most likely, whether this is COVID or any variant, they take care of it. The disadvantage, of course, is that natural killer cells, these natural killer cells have not necessarily memory. So it does not mean that you got asymptomatically infected and you had no problem. You just maybe had the cough or a sore throat or whatever, or you didn't have symptoms at all. That is not to say that next time around, you can still rely on that type of immune response. As I was saying, if you happen to get confronted with the virus while your innate immunity is suppressed because you have just, mounted some antibodies, then you're not in good shape. I mean, according to my humble opinion, you are susceptible. And that is the problem right now. During the first wave, I told my kids, at least, I mean, okay, you should not exaggerate, no mass gatherings or whatever, but please, go out and make sure that you keep in touch and that you keep contact, and that you keep exposed to environmental influences, because this is going to stimulate your innate immunity. Innate immunity is not an acquired immunity. It has no immunological memory. It needs training. It needs to be trained. And if you don't train it, I mean, it becomes weak and you become susceptible, right? But right now, I don't dare to tell them, please just, get exposed, no problem, you have good innate immunity. Why? Because now the likelihood that they will encounter the virus whilst having antibodies, even if they are not vaccinated, becomes higher and higher. And there are highly infectious strains around. So even for them, even for a perfectly healthy child, it becomes risky, and there are these cases, like in Israel, etc. Young children, perfectly healthy, no underlying diseases, that are now on ventilators.
So a lot of the supportive measures that we're taking, like taking immune boosters, your vitamin C and your D, your exercise and sleep, and all that sort of thing. And how important is that
I very strongly believe in this, and frankly speaking, I mean, you cannot make money with this, right? You can, with a vaccine, you can make money. With these things, you cannot make money. But I mean, there is a myriad of publications right now available that clearly demonstrate and clearly say that your innate immunity, and particularly the stimulation of your B1 cells, your B1A cells, these are really the B cells that produce the IgMs, the natural antibodies that are multi-specific, that this stimulation is, so much better in healthy people. And healthy means very simple, healthy lifestyle, exercise, so important. Have you seen any statistics of, death, mortality, and morbidity in people who regularly exercise? Good food.
Probably very, very low, very rare, I think.
Yeah. I mean, stress is bad. All the things we know, your mental attitude, even your mental attitude, right? Good food, exercise, have enough sleep, have enough rest, have stress like I do, but it's positive stress because I want to do something, I want to change something. But negative stress, all these things. But of course, people laugh about this, but there is now increasing evidence, even from this unbelievable, discipline, the neurosciences, I mean, just unbelievable, the progress made in this field, that is increasingly illustrated how, even our brain and several different regions in our brain are directly connected, interconnected with our immune system, and how this can have an impact on, yeah. But this is, of course, ignored because, and I've also been in the vaccine business. I'm still a vaccine guy, because you hear me saying, I think, the way out of this, you don't hear me saying, we should let the pandemic run its natural course. It's impossible. We have highly infectious strains right now. We have no longer the original pandemic. We have a new pandemic with several highly infectious strains around. And that is a very serious problem. And I think the only way to get out of this is really with a vaccine that eradicates. And whether it is an NK cell, whether it's an oral, I mean, there is no 25 different choices, but it must be a vaccine, a terminator, right? That can eradicate those highly infectious strains. Otherwise, we are not going to get rid of this.
A terminator vaccine.
Yeah, and I think, I mean, it's the first time I'm saying this. I think this pandemic will even change, the notion that we attach to vaccines. I think people will no longer use this name. I mean, I think it will go very far. Yeah, I think vaccines that are capable of preventing infection, those you can use during a pandemic. And, we need to coin another name for those. My preference would be terminators, right? Because then everybody would understand that this is going to end something. People now don't understand, where this is going, whether this is ever going to have an end, right? The end was herd immunity. Well, there will not be herd immunity, that we know. And in the meantime, we see more and more infectious strains going on. Nobody is able to predict what's going to come. You see these curves, people looking at those curves like they're looking at the currency rates on the stock market, right? But nobody dares to predict what's going on. Where are all these models, the modeling, etc.? Where are all these epidemiologists predicting, they don't even know whether it's going to go down or up. I mean, it's just a mess, right?
And then, I might have to shoot. It's almost 2 hours. You budgeted for 90 minutes.
Yeah. Well, you know, that is always the problem
fun.
if you keep me. Yeah, I mean, this is such an incredible thing, and if I start talking about this, it's almost like endless because there is so many things to say, there is so many things to clarify, there is so many science that has not been brought to the table. It's like endless.
It's hard to condense 25 years into an hour or so, I think. And I just need to ask you one question. And there are quite a few questions that we have here, and unfortunately, I can't read them off my laptop. I'm using my cell phone, so I can't even read them clearly because they're very small. Would you mind if we forward them to you, and then we can send answers back to them?
I mean, what you will need to do is that I encourage people because, you know, it's not like there is a big organization behind me. You know, I'm doing this with my nephew, my brother-in-law. I mean, nobody is in fact organized or has a background in doing this type of networking and spreading these messages, etc. So it's not like I have an organization, right? I mean, I don't even have time to read messages on LinkedIn or on Twitter anymore. But what I still do is to work on the science, to convey strong messages, and you know, to get the message, spread the scientific message as much as I can through interviews that have a very broad reach, right? And I encourage people in all these interviews and all the papers and the manuscripts that we post, and you know, also the references from the literature that I'm using, and all kinds of documentation that is relevant to the science and that is relevant to solving this pandemic is on the website, and the website will go live, I think, in 1 or 2 days from now. And I encourage people to consult as much with regard to their questions, and we have already dealt with a number of questions, because it's simply impossible. I would love to answer those questions, but I cannot. And frankly speaking, people are telling me, Geert, don't do this because, you know, it's no longer possible. It's no longer possible, and you have to spend your time on, you know, what is what is most important, and that is to simply have the scientific debate going on, and you know, to spread the scientific message, because I think we are all concerned. We're all in the same boat, and it will be a time of, I think, you know, great solidarity. It will be important because it seems like from the top there is not much that we can expect, unfortunately, if they are not even opening the debate. So it will be, I'm calling, you know, scientists, I'm calling all people who have, you know, common sense to join the discussion and join forces, that we can at least, I'm not, you know, not a revolution, that's not what I want, but at least open the scientific discussion with those who have the authority, you know, to decide and hopefully to change things, because this mass vaccination, it's not, you know, it's unacceptable, scientifically unacceptable. And we see already what is going on, and we will see more of this, of course, in the coming days and weeks. I'm not even talking about months. You know, virus is much faster to adapt than we think, right? Okay.
Well, I'd like to ask you on something else that probably won't make much money as well. And you obviously you know, been asked about the ivermectin and whether it works or not. But according to my research, that ivermectin does inhibit the virus from entering into the nucleus, and it blocks it from accessing the spike protein from binding from the ACE inhibitors, from the ACE receptors, sorry. And it also has an anti-inflammatory effect. So our authorities here are dragging their feet and trying to release this for human consumption. And because it's illegal, a lot of contaminated ivermectin has been floating around, and we struggling to try to get this off there, because if this is the way it works, that it will block the virus from entering the cell from the binding the ACE blocking it from binding the ACE receptors and blocking it from getting into the nucleus. Wouldn't this be something that we need to consider?
Well, you know, for this type of discussion, I would like to refer to McCullough. He's the dean of the University of Texas Internal Medicine, and I'm going to have an interview with him. Well, the both of us will be interviewed together on this coming Monday. He is, and I will forward you his name. I will forward you his name, so that you simply do a search. He is the absolute pioneer in early and the absolute, you know, expert in treatment of early COVID disease. I mean, he was the one who, you know, stepped up and was telling even up to, you know, the US government, guys, this is impossible. We cannot have a positive diagnosis of COVID and say people to go home and just wait till they get so severely ill that they must be hospitalized.
Exactly.
There was no intermediate treatment, and etc. And he's an absolute expert in this. I mean, I have a huge respect for this guy because, you know, instead of discussing all over the place and all kinds of guidelines and masks and prevention measures, etc., etc. I mean, he's doing something. He's acting, right? And he is, and with his intervention, he's able, and these are his own words, to prevent 85% of COVID patients from being hospitalized, right?
That's fantastic.
Yeah, it's fantastic. It's I'm so honored to you know, be invited together with him in an interview on this coming Monday. He will, of course, discuss these aspects, and I will probably more discuss about how the pandemic is going to evolve, because it means, from what we are seeing right now, that more and more hospitals will need to be prepared to treat young people, to treat children, right? Even and that is something, you know, that is a dramatic change also in the evolution of this pandemic. So, but I will forward his name. I mean, it will suffice to Google it in, and you will immediately. And also, a lot of papers. They have been publishing this really in peer-reviewed journals. But to shortly, briefly answer your question, what he says is it's not just sufficient, you know, to take hydrochloroquine or ivermectin or you know, one or the other anti-inflammatory or corticoid. It's really well, a cocktail has a negative connotation, but it's really playing on several different aspects, on the inflammation, for example, on the viral uptake, etc. So he proposes, you know, to intervene not just with one single drug, and many of those are off-label, but they are prescribed in, you know, a medically justified way, and it's all monitored. And he has dramatic success with this, and he simply cannot understand, you know, how all over the world, but especially in the US, you know, officials are dragging their feet, you know, to make this largely available to the population, right? It's like considered an untreatable disease, which is not true. Which is not at all the case, right?
Not
so
true.
There is certainly hope. There is certainly a perspective. But we need to stop to do stupid things, because, you know, this law of Hippocrates, you know, first do not harm, right?
No, absolutely, yeah.
Do not harm, for God's sake, right? So we need first to stop that, and then, you know, people need to put their heads together, no panic, on what we can do in terms of immune response, in terms of early treatment, right? And also in terms of reestablishing, you know, a number of things that have been disrupted and destroyed in our society, because of all, you know, of the crisis, because of the measures, because, you know, there is so many so many sorrow and pain, you know, and panic is certainly not a good cure for all of this.
Yeah, the collateral damage is too terrible. People losing jobs, and, you know, some old people in the old age home, they're dying on their own, and when they die, then visitors are not allowed to visit them. It's just too terrible. And I think maybe can we end off giving people hope, because this whole idea now, we got to just this whole idea I'd like to do is to end of this year with giving people hope that there are things on the horizon. And while we're waiting for the ideal vaccine to come along, what can we do and to slow down the third wave?
Well, I think very, very briefly, because I really need to jump into something else. But, very, very briefly, and I mean that need to be discussed amongst experts, etc. But what I was saying with regard to the youngsters, right? I think what is most threatening right now is antibodies they may have, not from the vaccine, I hope, but from previous asymptomatic infection. So if we could develop just a finger prick test, where people just, with, finger prick test, a little device with a membrane, maybe coated with antigen, where they could see, it must be reliable, of course, that they are truly negative. There is no reason for them not to go out and have contact. Because, as I was saying, if they have natural antibodies, the natural antibodies, they can deal with any coronavirus, right? But if they have antibodies and this innate immunity is suppressed, it becomes risky, even for a young child in perfect health, right? That is different from the first wave. But so there is a possibility if we could, but I'm not saying this needs to be tested, validated. I'm just, brainstorming. I'm trying to contribute. I'm trying to free, the youngsters, because it's terrible. The people who are vaccinated or who have been naturally infected, I mean, there is no way till we can intervene with, for example, a vaccine or with, a very efficient therapy that we protect them. Because as I was saying, if they have antibodies, but the antibodies will no longer protect them because there will be resistance, and people, they hate me when I say this, but I know that there is going to be resistance, right? And it's already progressing. Anyway, even if there is no full resistance, already right now we know, according to reports in Israel, efficacy against the South African, against Brazilian is barely 20 or 30%, right? So we need to protect them because they cannot rely on their innate immunity, because innate immunity was already pretty weak. For example, elderly people or those who got vaccinated, I mean, they are at risk of having their natural antibodies outcompeted, right? And so that is something that we need to take into consideration. I think we need to intervene in a way that is tailored to the immune capacity of the different segments of the population, right? And in the meantime, why not work as hard as we can on something that we will not need to replace like every year, like the flu, etc. Because I was saying, for example, natural killer cells, they deal with all coronavirus. If there is a variant, even a spontaneous mutation, we don't care. The vaccine will work because, natural immunity is per definition not variant specific. We just need to educate those cells in a way that they acquire memory. That's for sure. Right.
Sure. Time has gone fast, and I really appreciate you spending time. But may I ask one ENT question or two ENT questions?
Yeah.
Number one, what do you think? What do you think of the nasal vaccines that they are developing?
The nasal vaccine, my opinion is, of course, this is in a sense promising, because if you are injected intramuscularly, you will build an antibody response. You will develop systemic antibodies, and in fact, these antibodies need almost to transudate through the mucosa in order to be at sufficient concentration at the portal of entry, which is, for example, the respiratory mucosa. If you can induce these responses right at the portal of entry, I mean, you will be more efficient, that's for sure. But I don't think that this is going to solve the problem of immune escape, because at the end of the day, you still have, immune response against the S protein, and that is not going to be sufficient to eliminate a virus. During a pandemic, of course, again, if you use this as a prophylactic vaccine intranasally, I think this is fantastic. This is fantastic, but we are in the midst of a war. And when we get injected, we need to load our weapon, and that's where we become vulnerable. And that is something NK cells, for example, can deal with. because as soon as the cell gets infected, they can eliminate the infected cell. So that is a completely different. It's not antigen specific, so you cannot have selective immune escape. Select for what? It's not antigen specific, right? So am I convinced? Yes, in fact, I'm convinced that even mucosal vaccines will not be a solution for solving this pandemic in the situation we are right now, because even those vaccines will not be able to prevent immune escape.
So, and then one final one, I'm not going to let you go. Thank you so much. When we treat sinusitis and we treat allergies and sinus conditions, we normally get patients to rinse their noses out with saline and warm saline, things like that. And then we use the nasal sprays and that sort of thing, just to decrease the virus. Especially now with COVID, we can actually rinse some of the virus out of the nasal mucosa. And in decreasing the viral load, wouldn't that help with some degree for the body to be able to respond to that? That's number one. And number two, what do you think of the beta povidone iodines and the colloidal silver and things like that people are using to nebulize?
You remember I promised I would forward you the name of the guy?
Yes.
He's exactly the one. He's exactly the one who is using this in very successful ways. But in combination, and all these questions, you will have plenty of answers. I will forward you his name now immediately, because otherwise I will forget. And you look what he's writing, and with many other colleagues, they are now in fact almost like forcing the US government, to turn this in a law in the sense that you are no longer allowed as a physician or whatever to send patients home with a positive diagnosis of COVID without providing them immediately with therapy, with early therapy, right? Yeah.
Fantastic. And we've got to give them hope. Every time they leave our office, they've got to leave us some hope and not just go home.
Of course.
And depressed and child abuse and home abuse, domestic violence.
I know. So, I promise I will forward you that name. And
thank you very much.
Yeah, if you guys, I'm not making propaganda, not at all, but help us in spreading the message, because I hope you realize and you appreciate that what I'm telling, it's science. It's not like guys, I'm an anti-vaxxer and please stay away from vaccines because you're going to get I don't know, Alzheimer, or you're going to get autoimmune disease or whatever. I'm not at all into that type of debate. So help us to spread the message, especially to scientists and people who can maybe also support us more internationally, right?
Yes, so we've got I've got a colleague in America. I've got some people from Canada, Mauritius, and I think some parts of Africa as well. And we'll be posting the links to this. We're going to post this.
Please, and send us the link if you have recorded this, right?
Yes, we have.
Yeah, send me the link as well. We can post it on our website as well.
Yes. Okay. We'll certainly do that. And then once again, hartelijk dank.
Met plezier gedaan. Met plezier gedaan. Which means with pleasure. My pleasure. Okay.
Yes,
good.
Thank you.
Gonna leave it there. Take good care.
Yes.
And
thank you so much.
Stay healthy.
Right. And one last thing, to the ones who posted questions, we'll try and find answers for them after the thing, because we recorded this webinar, and we will try to provide answers to those who ask questions. And I apologize, I couldn't read them because I'm using my cell phone now.
No. But look at all what we are posting, in the next coming days on the website, and I'm sure you will find a lot of questions on those. But of course, I'm looking at this from the infectious, from the side of infectious disease, immunology, and vaccinology. I'm not, of course, the expert in early treatment, but as I was saying, as we speak, I will immediately forward the coordinates of this of the guy, and you will have plenty of answers to your question. Okay.
And before you say goodnight, what is the website address? What is the website address?
Well, we don't have it. We don't. It's yeah. My nephew is taking care of this. I think he worked all day on this, but we will share it. We will share it.
Okay.
Definitely, it will be on LinkedIn.
Thank you.
The link will be on LinkedIn. The link will be on Twitter. You cannot
So
miss it.
Okay, we will do.
Okay.
Well, have a good night. Thank you so much for spending your precious time.
My pleasure.
I know you're very busy, and have a good night's rest. You deserve it.
Okay. Okay.
Thank you.
Care.
Thank you so much.
Bye-bye.
Bye-bye. Hi, everybody. Thanks for staying on till the end. It was a long webinar, and we will be posting this in the link. But I think it seems like it's quite scary, but vital information we all have to know. And I wish you all a very good night. And apologies, my internet bombed off twice, and so I just had to log on back on with my cell phone. But thank you very much for attending, and have a very good evening, and have a pleasant week next week. God bless you, and keep you safe. Thank you. Bye-bye.